At this point, we're handling corrupt packets. What about lost packets? So what if the sender sends some data out, it does UDT send, and now it's waiting for an acknowledgement, but this sent packet gets lost. In that case, the receiver never gets a UDT receive for any of these actions, and so it will have no reason to send a packet back. And so the original sender will just stay stuck in this wait for ACK state. Since we don't want to stay there indefinitely, what we do is we create a timer that will periodically trigger a timeout event, similar to the way that something is waiting to receive packets. It's waiting to receive packets, or it's waiting for that timeout alarm to fire. And in that case, it does the same thing as if it had received a negative acknowledgement. It tries resending, stays in the same state, and so it's going to resend and wait for acknowledgement, or wait for another timeout, and keep going. Finally, the last question has to do with duplicated or reordered packets. And we already handle duplicated packets to some degree. If we sent a packet for phase 0 out to the receiver and it gets duplicated, the receiver will see two phase 0 packets. So the first one will acknowledge as good. The second one, it will send a NAC for phase 1, and that will get things back in sync already because the sender will have been waiting for that acknowledgement for the first packet. It will have received it. It'll receive a NAC for the second one, but it's not paying attention to those, and so it just continues to wait for the application. And if we change from having 0 and 1 states, represented in the state machine directly, to just a number, a counter sitting on the side that we update as we go from the wait state back to the wait for the application state, then it doesn't fit as prettily in the state machine, but it works more generally, and it lets us detect packet reordering more generally, as well as duplicated packets. So as we will see, that's what TCP will do. If this basic state machine is right, we can just add a counter on the side.